Characteristics of quadratic functions. There's a lot of things you need to know about quadratics before you can really do anything with a quadratic. And they're kind of fun, I think. So we're on quadratic functions. Jada, what are we sorry for? I'm not even watching the chat box, you guys. I don't know what sorry means, but we'll just move on. I'm not watching the chat box. You're going to have to unmute.
Miss Mawson, no, she unmuted and there was background noise. So
oh, okay.
Remuted.
Okay. Thank you. Quadratic functions. The first and foremost, the biggest thing you need to know is the standard form. What do they look like? Because we know the linear functions, we were used to seeing y equals mx plus b. We knew that was linear. We have a slope, we have a y-intercept. It represents linear. What represents quadratic? What represents quadratic is y equals ax squared plus bx plus c. This is quadratic. And it's quadratic because I have a squared term. If you have a squared term, that is quadratic. Understand that a, b, and c are numbers. So A, B, and C are numbers. What might it look like? It might look like, I'm going to write X for example. It might look like y equals negative 2x squared plus 3x minus 5. A, B, and C are numbers. So in order to identify, and you have to be able to identify what is A, what is B, and what is C, A is always the number in front of the x squared. B is always the number in front of the x. And C is the number that has no variable. So therefore, down here at this example I gave you, A equals negative 2, B equals 3, and C equals negative 5. Make sure everybody understands that. Do you understand that? Write that down. That's going to be important. Oh, you did? Okay. So you have to be able to identify A, B, and C. And the reason why is because quadratics form a graph that is called a parabola. I think I touched on that the other day. So a graph of a quadratic is called a parabola. And a parabola either is a graph that looks like it's smiling or it looks like it is frowning. Those are the only two ways that that graph can look. It cannot look sideways like a C. It has to look like it's smiling or it's frowning, and it can be anywhere on the coordinate plane. Well, I can determine whether my graph is smiling or frowning based on the term A. If A is positive, that's the A up here I'm talking about. If A is positive, well, what are you when you're positive? Are you smiling or frowning if you're positive? Smiling. You're smiling. If A is positive, your parabola is smiling. And if A is negative, then you know the answer to that. The parabola is frowning. So if your A term is positive, your parabola looks like this, and this is really important once I start showing you the parts of a parabola. If your A is positive, you're smiling, and if your A is negative, you're frowning. Yes?
So in this case is no.
Can you say that louder?
In this case it's negative.
In this case, I gave you a negative, so that means that parabola would look like this. It would be definitely frowning. Okay? So this is some preliminary stuff that you need to know. And now we're going to start looking at the actual parabola itself. And we're going to show you what you're dealing with. Are there any questions about what I have done so far with this? Any questions? Okay, I'm going to erase, and it's all going to be taped. This thing is videotaping. Okay, so we're going to look more closely at an actual parabola, and we're going to talk about the parts of a parabola. Okay, a parabola can be anywhere on the coordinate plane. Hold on a minute. I will always think about Miss Bush when I use this, because she gave this to me. She said she had bought it off of Amazon or somewhere, and then she was teaching Math 2, and she never needed it for Math 2, so she gave it to me for Math 1. And I was forever grateful, because it's a great tool to have. So your parabola can be anywhere on the coordinate plane. Your parabola could be way up here. Your parabola could be like this. Your parabola could be like this. Your parabola could be like this. It could be anywhere on the coordinate plane. It just depends on the points as to where it lies. Okay? So let's go ahead and look at the characteristics. Let's take it apart and look at what a parabola, all the parts of it. So I'm going to make one that's a smiley face. Okay? That is a parabola. Even though this doesn't come all the way up, it does eventually because the arrow says it does. These arrows say it just keeps going. Okay, well, there are things about the parabola. First thing is the vertex. The vertex is either the very lowest point if it's smiling or the highest point if it's frowning. So my vertex would be right there. That is my vertex. That's the very lowest point on the parabola. If it was a smiling parabola, it would be the very top point on the parabola. Now, at the vertex, there is an imaginary line that you will never see. It's an imaginary line that goes right through and cuts this parabola in half, and that is called an axis of symmetry. And we also refer to it as the AOS, axis of symmetry. Okay? Now, we always, it doesn't matter where this parabola is, we always have somewhere a y-intercept. Always have a y-intercept. And with this parabola, we have two x-intercepts, but you don't have to always have an x-intercept. Because if my parabola was up here, it would never hit the x-axis. But in this case, I have an x-intercept here. And I have an x-intercept here. Now, something about these x-intercepts, they're really, really important things. Even though we don't always have them, they're very important. X-intercepts are called multiple things. I'm going to write over here x-intercept. Let me turn this, because they are called multiple things and you need to be aware of them. The x-intercept is also called zeros. called, what else they called? Solutions. Usually we call them solutions at this level in math, and when you get up into the higher levels, they start calling them zeros, but we're going to refer to it as both, so you're in the habit of it.
Miss Monster, can you move the screen a little more over?
Oh, I'm sorry. I've got the one screen going, but not that one. Okay. So your x-intercepts are also called your zeros or your solutions. They used to be called, I'm going to put it there in case somebody refers to it. It used to be back in the day, 20 years ago when I was teaching, they called them the roots. So they're very, very important. Not all parabolas, not all quadratics have roots or solutions or zeros. Not all of them do. Many of them do, but not all of them. Where would a case be that it doesn't? If this is my coordinate plane and my parabola was up here, notice it never even touches the x-axis. Therefore, that would not have any solutions. There would be no solutions or zeros to this, none. Or if my parabola was like this, there would be no solutions. It's not going to get any higher than that. So there wouldn't be any solutions. But if they did something like this, even though it's down below it, these arrows mean it keeps going. So this one will have solutions. It's just not showing it in that picture. So we have the vertex, and today we're just going to focus on the vertex and the AOS, the axis of symmetry. We're not going to focus on the solutions today. There's a lot involved with solutions. And I don't want to give you too much new stuff before we go on spring break. But I did want to at least start with this. So we're going to focus today, and we might even focus on the y-intercept because that's so easy. And I'll show you what I mean in a minute. But we're going to talk about the vertex and the AOS and probably the y-intercept. We already did domain and range, so you should be able to tell me the domain and range of a quadratic, but we'll probably deal with that after spring break as well. So, for today's lesson, and if you'll look at that worksheet that I opened up for you, let's go ahead and open that up and look at that and see what we're dealing with. So we're going to open up, I'm going to share my screen. Just so I can show you what I need you to have opened up on your computer. And we're not going to be doing all of it. So if you look at your computer right here for today's date, 3:30, characteristics of a quadratic function. And this is the worksheet that we're going to be working with. And we're going to work with the vertex, the axis of symmetry, and the y-intercept. I think just those three is all we're going to talk about today, is just those three. So on this first problem, it says find the vertex, axis of symmetry, and all that other junk, which we're not going to do, of this particular graph. So let's look at that first problem. Yes. Sure. Okay. So that very first problem is f of x, which is the same thing as y. Same thing as y. F of x equals 3x squared. First of all, I know for a fact that this parabola is smiling. And I know it because my term A is positive. So this parabola is smiling. I do know that. Okay? I also know about this parabola. I know what A equals, I know what B equals, and I know what C equals. I know A equals 3 because I told you that's the number in front of the x squared. B equals 0 because there is no x here. And C is also 0 because there is no other number here. Remember standard form? Y equals ax squared plus bx plus c. All I have is an A. That's all I need. As long as I have an A that's squared, that makes it quadratic. So, I want to tell you this first.